I welcome you all in this lecture. In this lecture, I'm going to talk about the introduction to operational research, and this is the content of today's lecture. So first of all, we are going to see the definitions of OR, concept of model, and classification of model. So first definition is OR is a scientific method of providing executive departments with a quantitative basis for decisions regarding the operations. So this OR is a scientific method which provides a quantitative data, a quantitative base for taking the decisions to executive departments. And we know that the decisions taken on the basis of a quantitative data provides good outcomes. Second definition is it is a scientific approach to problem solving for executive managements. So executive management always face some problems related to different operations like allocation of men, machines, or use of material during the certain operations. So such problems are solved by using techniques of operational research. So this is defined as a scientific approach to problem solving for executive management. Now third definition is OR is the application of scientific methods to problem arising from operation involving integrated system of man, machine, and materials. So we know that during the operation we required manpower, we required machines, and we required raw materials. Okay, so the problem arising from this integrated system of this man, machine, and materials are solved by this scientific method that is known as OR. Okay, so OR is the application of scientific methods to solve problems arised from the integrated system of man, machine, and materials. Now what type of problems are arised in the integrated system of man, machine, and materials? So as I told you in the previous definition, so allocation of manpower to different projects, allocation of manpower to different tasks given in the industry, allocation of machine for different types of products, and use of material, raw material, to produce a different type of product. So appropriate amount of material has to be allocated for different types of product, and this allocation of man, machine, and material is totally depend on the profit that is obtained from that product or process, or the cost of that product or process. The right combination of man, machine, and material is allocated so that the executive management get the maximum profit, or they can go with the minimum cost. So this is the approach which is followed in the operational research. Now the next concept in operational research is model. So it is a simplified and often idealized representation of reality or the system. Okay, so it is just a representation of a reality or system, is nothing but the model. The main objective of a model is to provide means for analyzing the behavior of the system for purpose of improving its performance. So first of all, this system or reality is represented in the form of model, and this model is required to analyze the behavior of the system. Okay, because many times we cannot actually analyze the actual system. So what we have to do, we have to use the representation of this system, which is called as model, and on that model we can perform the analysis and we can check the possibility of improving its performance. So there are different ways to classify these models as follows. So first classification criteria is by structure. So first type is iconic or physical models. The physical representation of real system with a different scale is nothing but the physical model. So in the physical model, the system is represented physically with a different scale. Example: map, images, paintings, model of car, etc. So in all these examples, the size of real system is different, and this the size of that system, which is represented in the form of maps, images, paintings, or in terms of models, physical models, the size may be a reduced one. Okay, and these are produced just for the analysis purpose. Second type is analog or schematic models. In the analog or schematic models, it is represent the dynamic situation. So schematic models represent the dynamic situation, like a graph that represents growth of population in terms of distance. Okay, so you might have used different types of graphs in which we represent the actual system in the form of distances. That is, we take some scale on the x-axis, some scale on the y-axis, and we represent that reality or that system in the form of graph. Just like if you want to represent the speed, variation of speed with respect to time on a graph, so we have to assume some scale for time, you have to assume some scale for speed, and you can represent this variation of speed with respect to time on this graph. Okay, so we can say that this schematic models represents the dynamic situation where one thing changes with respect to another. Third is the symbolic or mathematical models. Now these symbolic or mathematical models are the models which represent the decision variables under study using mathematical symbols such as numbers and letters. These symbols are then used in the equations which describe the properties of the system, example linear programming. So in these mathematical models, the actual decision variables can be represented in either in the form of numbers or letters, and these numbers or letters can be used in the equations, and then by solving this equation we can actually find out the decision variable, the value of decision variable, which can be provided further to the executive management for taking the decisions. Second criteria is by function. First type is a descriptive models. Now descriptive models explains various operations in non-mathematical languages. Okay, so as we discussed in the previous, mathematical model represents the decision variable in the form of numbers or letters, but here this descriptive model represents the various systems or operations in non-mathematical language. For example, observations, surveys, questionnaires. Now these all observation tables or surveys or questionnaires consist of non-mathematical language, that is in the form of some descriptions this observation, survey and questionnaire is prepared. Second type is predictive models. Now these predictive models explain or predict the behavior of the system. For example, forecast model predicts the future sale or future demand. Okay, so this forecasting model is one type of model which can be used to predict the sale or demand that is going to occur in the future. Okay, so it is used for the forecasting. So this model, forecast model, is used to predict the behavior of the system in the future. Third type is prescriptive model. Now these prescriptive models are used to prescribe the certain optimal solutions for problems. Now there are certain models in the OR that can be used to prescribe the solutions to another problems. Okay, but that problem must have the same type. For example, linear programming models. If you make or if you prepare the model for certain problems, and if the variables of that system changes, then also we can use this same model for that system. Okay, that means if certain variables of the system changes, we can use the same model to prescribe the solution, and that is nothing but the example of this prescriptive model is the linear programming models. Now the third criteria is by nature of environment. First type is deterministic models. Now here the variables are completely defined and outcomes are certain. So if the variables we can define completely, it has a certain meaning and its outcomes are certain, then that model is a deterministic model. Example, a linear programming, transportation problem, etc. Second is probabilistic model. is the model in which at least one parameter or a decision variable is a random variable, that is, it cannot be predicted, it cannot be defined completely, are called as probabilistic models. Changes in the variable cannot be predicted. As I said, these variables are a random one, so we cannot predict the change in the variable completely with certainty. However, it is possible to predict a pattern of values of the variables by their probability distribution. So this probability distribution is very important concept which is used to predict the pattern of values. Okay, we cannot predict the change in this variable, but at least we can predict a pattern of values, change in the values, its pattern can be determined using probability distribution. Example is probabilistic inventory models are used in the conditions of uncertain demand to decide economic order quantity. So in certain situations, the demand is uncertain. In the future, how much will be the demand, that cannot be defined in certain cases. So in that cases, this model, that is probabilistic inventory model, can be used to find out the economic order quantity. Fourth criteria is by behavior. First is the static model. They are used only for a single time, and it represents the system at a specified time and do not consider the changes in the system over change in the period of time. So static models are used at that instantaneous time. Okay, so it cannot consider the change in the time, the change in the system over the period of time. Example, economic order quantity model. Second is a dynamic models. So dynamics models can be used for multiple times on similar problems and used in a situation where time plays important role. Also used for optimization of multi-stage decision variables. So in the optimization of multi-stage decision variables problems, we have to use the multiple decisions, and the outcome of next decision depends on the outcome of previous decisions. Example, dynamic programming model. So thanks for watching this video.